but we leave you a challenge.
Okay, 2 seconds back. Sorry, Matt forgot to record. So the big thing here is you'll note after we graphed the parabola and the two lines, what was the difference in the top minus bottom, dudes?
Things and
It
stuff.
had different.
Yeah. Different bottoms, yeah. The bottom is different, so therefore we broke it at the black line and separated it into two integrations. Still doing top minus bottom, it's just that the bottom function changed. That's probably fairly common. Okay, this second one is the one we're in the middle of, and we just had the great debate with this ugly x plus y squared equals 4 equation. If you did solve it for y,
I thought every equation was beautiful.
well, that was an ugly one to graph. If you did solve it for y, you got this plus or minus square root of 4 minus x, which is a pain. And it's actually easier than we solved it for x, and we plotted it sideways. Okay, class, explain for him. What does the plus 4 do if you're going sideways? We went, instead of going up 4, we went right 4. The negative meant instead of being a downward parabola, it was a...
Wait, I got a question. So if there's a parenthesis in there, do you go the opposite? Like a parenthesis y?
Oh, okay. Alex is asking me if it was something like y plus 2.
Does that go down to?
Okay, since that is y, yes, that's the y coordinate. That is down to right 4. It's just backwards. Yeah. It's going to play with your brain a little to do sideways. But we're going to do sideways several times in the next week or so you'll get better at it. Sideways is a little weird. Now, the second one is just a plain ordinary line. So you can, how do you want to, what form do you want to change that equation into to graph the ordinary line? I doubt you want to leave it as x minus y equals negative 2. You could. But would you want it turned to normal y equals, or do you want to leave...
It's y equals x plus 2.
Okay, so yeah, it would be y equals x plus 2. So that one you can just graph normally. It's going to have a y-intercept at... So I'll jump on that one once. At 2, thank you. And a slope of 1, positive 1. So if I just extend my line, oh golly gee, look, it hits nice coordinates. And did I get a region enclosed by both functions?
Yes, we did.
Yes, we did.
So what's the top?
Yeah, there's the question of the day. How do you do top minus bottom?
No.
Yeah,
The
right
line
there.
minus the parabola.
The right minus the left.
Yeah.
Oh.
I already said that.
Yeah.
I
Caleb,
don't
yep.
wanna hear you.
Yeah, Caleb really did say it, but you know, you both got it, yeah. Since, why can you absolutely not, even if you wanted to, why could you not do top minus bottom?
Because you can't do.
Over here on the right, it say positive 2. Your top minus bottom is the same function. It's the same parabola. How can you take it minus itself?
Wow.
So you couldn't do top minus bottom. You can't take the parabola minus itself. So you have to do right minus left. So yes, if you're going sideways,
Flip it.
it's right minus left.
I like the turning the paper idea.
No, I turned my paper and that's when I was like, well, I'm gonna get one.
So think right minus left. So now, here's the other wrinkle. If you're going to do right minus left,
You gotta stop at the 0.
which way do you have to have your equations written? Should they be written y equals or x equals?
Y equals.
X equals.
Y equals is when we graph normal,
Y.
So x equals, it'd be x equals.
because this parabola we changed to x equals negative y squared plus 4. So if you're going to do sideways, all your equations have to be x equals. And that is going to be true throughout this entire chapter with all the different methods I'm going to teach you. If you are going sideways, it is x equals. Guaranteed every time. Put that in. So this equation of the line is in the wrong form. So yeah, this equation of the line, we need to change it to y minus 2. X equals y minus 2. So both equations are x equals equations. So then we can finally integrate it. Don't do the numbers right now. Let me get the function first, then I'll talk about how you know the numbers. Which is right, which is left? The parabola is right. And the parabola is this x equals negative y squared plus 4. So you're going to do the negative y squared plus 4. That's your right-hand function. You're going to subtract. Your left-hand function is what? y minus 2. And yes, it has to be a dy. Now, where do I get my numbers that are the limits on my integration?
2 to negative 2, or negative 2 to 2. Wait, no, negative 2. Wait.
Negative, or 3 to
So
Negative 2 to
the question is, do I look at the x-axis or do I look at the y-axis?
There are two.
Yeah,
The
if there are y's in the problem, if you see y's in your problem, you get the numbers off the y-axis. So in this case, you're looking for how low on the y-axis did this go.
When it gets back to 0, then you
So that lowest point is negative 3.
Yeah, but how do you get to the axis? Because if you do it to the axis, then you gotta fill in that little spot right there, don't you?
Okay, I'm confused what you're calling how do you do the axis.
So whenever it's going to the axis, wouldn't it be like the other side of it, like put your finger?
Okay. Oh, you mean when it's finding the area?
Yeah.
Okay, but what it's doing is it's finding the area between the function and the y-axis now. When we went sideways, they're finding the function to the y-axis and the function. So this is a positive area.
There's
This
this
is
point right here, you're finding the, wouldn't you be finding the area like right here?
I can't see.
In this little section right here? I think that's going to the west.
No, because you're doing the y-axis.
Oh, this,
Yeah, you're.
that's the x-axis you just pointed to.
Oh, you have it turned sideways?
This is the y-axis, so like this section right here. Wouldn't it be finding that? I'm just confuzzled.
Yeah, okay, this is, but it's taking this, it's also doing the lines area to the y-axis,
Okay,
it's
alright,
subtracting
that
that area to
makes
the y-axis, just like it was with up and
It
down.
was a valid question, I was confuzzled.
It is a valid question, just took me a minute to figure out what he was talking about. Okay, so how low did you go on the y-axis?
pretty low.
Negative 3.
-3 would be the lowest point, the highest point up the y-axis would be 2, whoops, you can't see that. So it'd be -3 to 2. Okay, another thing I'm going to show you, and right now you're going to go, well, why would I want to do that? It's not going to matter.
It is gonna matter.
It's going to matter when we get to volume, you're going to want to do this. It will help you. And so the sooner I can, the more days I can say this to you, and better, the better. Okay, you remember when we actually found area by adding up all the little, dividing up into little rectangles, letting the little rectangles get all skinny until we could sum them all up?
The limit.
Yes, with the limit, that's what integration does, okay? On a normal function that you've just been doing, it's like our rectangles would be sitting here going up and down. We're summing up all these little rectangles. Okay, if you draw them in there, it will show you whatever the function is hitting on top is your top function, whatever function is touching on the bottom is your bottom function. So if you're in doubt, if you draw the little rectangles in there, you can see the top and the bottom. That's why over here, you would know it's different, because I'm touching a different bottom now when I put the rectangles in. When we get to volume, it's going to be helpful to put those rectangles in there. Okay, however,
So you want us to put the things in
okay, so here, which way would the rectangle have been sitting?
sideways?
The rectangles would be sitting sideways now. That also then helps you if you're trying to decide, okay, well, what functions do I use? Well, which function is it touching on the right? Which function is it touching on the left? Because this can get more confusing, sorry to say. But that will help you massively when we get to finding volume. Next class, we're going to take and revolve that whole thing around an axis and make a volume out of it.
Neato.
It will help. So thinking about where the rectangle, anytime the rectangle is sideways, you're going to have y's in the problem, you're going to be doing sideways functions. If your rectangle is sitting up and down, you know you're going to have x's in the problem, and you're going to get your limits of integration off the x-axis. And that's going to hold true for every method I teach you.
So what's the answer to that?
Oh, what is the answer to that? That's a really excellent question. The answer to that would be 125 over 6.
So we're gonna do that in the calculator?
Well, actually, if you read your assignment sheet today, I believe you'll see that it says, you have to do at least 2 of them by hand. Your pick. Okay, this one, once again, this one's simplified. This one would be pretty easy to do by hand.
But this seems like a good test.
Yeah, it is.
I hope we don't face that later.
Such a good test, I usually have bad tests.
No.
Well, you guys kind of were backwards on the first one of the year, so, but don't usually.
First one of the year was just bad.
Or the first, no, I mean the first one of this semester. Usually optimization's a little better than it was. But you seemed like you were really doing well with integration, so I'm expecting integration to be better. Okay, so
Came back from summer.
I'm thinking another sideways example might be a good thing.
Yeah, do it.
Yeah. Okay, this particular problem was an accident. That it happened one year when they said, throw another problem up there, and I invented something without knowing and thinking ahead. It's proved to be a great learning tool. So I drew them one like this. X times y equals 1. And x plus y squared equals 10. And I said, okay, let's find the area between these two functions.
Same with math family. They didn't find anything. Area?
Okay, so how on earth does one graph x times y equals 1? Have you ever seen that?
It's just the hallway.
Isaac, stop being a distraction.
It's a hallway.
Why does Alex think it's a hallway?
What?
'Cause if okay, and we got to decide. Well, which way do you think? Do I need to solve this as? Do you want to do it y equals? Do you want to do x equals?
Wouldn't that just look like a negative hallway if we do a sideways line? To me, it's the same thing.
Because if you, I'll actually solve. It can either be 1 over y, or if you solve for y, it's going to be 1 over x. Okay, when it comes to getting it graphed, put it in whatever form is easiest for you to get graphed. Don't worry about what form you need it in to actually do the integration at the moment. Do whatever you need to get it graphed, then change it to the right form if you have to. But in this case, is it a hallway? Is he right?
It's the opposite of
What makes it a butt crack?
negative hallway.
Squared, 1 over x squared. So, yeah, this is a hallway. Okay, do you remember how to graph a hallway?
Bottom left, top right, but this one should be the top left, bottom right.
Yeah.
Yeah. Okay, normally this is y equals 1 over x. If I solve for y, this is a normal hallway. This is not shifted or anything. This is a normal 1 over x hallway. Okay, probably if you can manage to not put the asymptotes on there, they're gonna get in your way and be messy. So, do you remember where you plot the curve? The bend of the curve? Yeah, since it's the one on top, you're just gonna plot points at 1, 1. Oops, can't see white. You're gonna plot points at 1, 1 and -1, -1, and you're just gonna draw curves toward the asymptotes, which we aren't actually gonna draw in there though. So, where are we going to intersect? That will be interesting.
Multiple places.
Multiple places, we hope so. Okay, so what's the other one going to be? Why does she know it's a sideways parabola?
Because it's,
The exact same thing as it was.
It's y squared, not x squared. So yeah, it is going to be a sideways parabola. So I would probably just change it. It's negative y squared plus 10. Okay, so the 10 shifted us which way?
to the right.
We went right 10. Which way is the parabola going to come? Is it going to curve to the right or curve to the left?
Left.
To the left.
It's negative, so yes, it's coming back to the left. So we got to go right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plotted right there, and it's got to come backwards to the left.
What is the
1, 1. And if you want points, you can just, all you're doing is flipping your coordinates. Just do your 1, 2, 3 on the right, your 1, 4, 9 on the left. Actually, I may need 16 to get this one. Okay, so that's, I got to come 4. 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3.
You gotta do
10, 11, 12, 13, 14, 15. If you want to do 16, we can do 16. But yeah. Is this intersecting nicely? Not really. I even missed totally and completely with those. I should be a little farther out. But yeah, I'm not hitting the blue and the black are not hitting at nice corners of graph squares. They're hitting at some bizarre fraction. Oh goody. So, is there an area we can find? Are they enclosing a region somewhere? Yeah. We got a region. So we get this. Oops. Doggone it, it did it again. It just doesn't want to switch the highlight.
You guesstimate on the fraction?
No, we guesstimate nothing. We use math. So that's the part I'm after. Okay, we need to know where they intersect. Okay, you have to do algebra. Time. That's okay. I can run touch over. All right. So if I want to do actual algebra here to solve this, guys, when they intersect, isn't that where they equal each other? So anytime you need to find the intersection points, all you do is set the two equations equal, and so I will solve for it, and you'll find the intersection point. So now the question is, since this one is x equals, I need to use the other one as x equals. They both got to be in the same form. So I'd be saying, where does 1 over y equal negative y squared plus 10? Like I said, remember, this problem was accidental. I slapped some graphs up there and then, ooh, this is an interesting problem. How on earth do I solve this? I would times by y and ditch the fraction. Okay. So I would get 1 equals negative y cubed plus 10y. Oh, isn't that sweet? I could, but it's equal to 1. It's not equal to 0. Okay, then I do, if I subtract 1, am I going to get anywhere?
Pull a y out before you move that one.
What good will it do me?
I don't know.
It'll get you back over to 1 over y. You gotta
So,
factor this business.
okay, well, do we not factor that with the y cubed?
Well, we can do longitude.
Okay, if I was going to make you do it all by hand, you would have to try to find the number that makes it equal 0 and do the synthetic division thing would be the only way you could get this to factor.
Yeah.
Or if you have a calculator, what can you do?
Solve for 0.
You do a solve, yeah, set it equal to 0 and solve it and see what your calculator tells you. So, I would not make you go to all of this by hand. So yes, you would do a solve with it equal to 0, and are you dying to know what it comes out to? Anybody got good estimation skills? I am not drawn perfectly accurately enough, that's for sure.
3.12.
Really? Seriously? No,
I'm gonna go 17.
it actually is 3.11.
I was pretty close.
Oh, that's sorry, that's not y, that's x. Sorry, that's y. I keep writing x, but it's y. You'd have a y coordinate. You're solving for y here, so you're looking at what y coordinates would you be at.
And then the other would be...
The other one actually makes logical sense. It's 1/10. Out here, where would those two be intersecting? It'd be 1/10 up because.
What about down there?
What about down there? What down there? Oh, okay. Down here, yes, there's an intersection point down here.
That goes on forever.
But are we trying to do?
But would it be the same thing as the negative?
Yes, it would be the negative. Yes, yeah, it would be the same. So, but that one goes on. It doesn't ever. This one's not going to enclose anything because it's going to keep getting wider. We're never going to get an enclosed region on the left side. So with those, yeah, can you go ahead and set up an integration? Yeah, we can. We know we're going to integrate between what numbers?
0.1 and 3.
There you go, 0.1 and 3.11. And we're going to think top minus bottom?
No, right by the bottom.
We're going to think right minus left. And so if you drew a little rectangle across there, look at it go. What am I touching on the right? What am I touching on the left? Well, on the right, it's the parabola. So the parabola has to come first, and it was the negative y squared plus 10 minus the left-hand function is what? 1 over y. And with a dy, thank you. And, you know what? I don't have the answer to this written down.
Wow.
Are you serious?
I don't know the answer.
I got 3.11.
Okay, so I'm stopping it, sorry, but.